Okay, now I want to show you how to construct an helix. How to construct an helix. An helix is one of the curves that we do construct in technical drawing. And a simple description of an helix is that an helix is the locus of a point which moves around the circumference of a cylinder. An helix is the locus of a point which moves around the circumference of a cylinder, and at the same time it moves axially along the length of the cylinder or the height of the cylinder. Okay, this is a cylindrical object. So the circumference of the cylinder that we are talking about is this part. As I'm moving my finger around this cylindrical object. So this is the circumference of the cylinder. And in the definition we also have that the locus or the curve is also moving axially. Axially simply means the movement of the curve from this end going in this direction and end on this part of the cylinder. That is the axial movement. It is moving round and at the same time is going like this axially. That's what we mean by axial movement. Okay, now I have something to show you so that you can understand what I mean by helix. Now look at what we have here. This is a paper tape that I've wound round this cylinder. Now look at the movement of this paper tape. It's moving like this, moving in this direction and end here. You can see the starting point and the end point. So this paper tape on this cylindrical object simply shows the movement of that point on the circumference of the cylinder, and that curve is known as, or that locus is known as the helix. Is known as the helix. Now there is you need to know that we have two forms of helix. An helix can be right-handed and an helix can be left-handed. It can be right-handed and it can be left-handed. Now, if it is a right-handed helix, it means that someone is standing somewhere here, looking at this end. Looking at this end here. Someone is standing here and looking at this end, and the curve starts from here. Look at the point. It starts from here and it is going on the right side. It's going like this, moving in this direction, starting from here and moving like this. Okay, so when the movement is along this line, starting from this left side and going on to the right side, we call that type of helix, we call it left-handed helix, or we call it left-hand helix. But if it starts from here, and going in this direction, that is what we call right-handed helix. It starts from the right and it goes to the left. So we call that type of helix, we call it left-hand helix. Okay, now in the construction of an helix, whenever you are asked to construct an helix in technical drawing or in engineering drawing, two things will be given to you. Number one is the diameter of the circular base of the cylinder. The diameter of the circular base of the cylinder will be given to you. That is number one. And number two, the lead will be given to you. The lead is the axial movement of the helix. The axial movement of the helix for one complete revolution is known as the lead. So what I mean is, when the point starts from here, and it goes round the circumference of the cylinder and end here, so the movement from this point here, where this paper tape starts from, the movement from this point to this point is known as the lead, because it has moved round the cylinder and end here. It's like you start from a particular point on a circle and you move round and come back to that point where you started from. That is one complete revolution. So the same thing applies to this paper tape. It starts from here and it goes round the cylinder and end here. Okay, so the distance from the starting point to the end point is known as the lead. So two things that will be given to you for the construction of an helix in engineering drawing or technical drawing is the diameter of the circular base of the cylinder and also the axial movement for one complete revolution, which is called lead, will be given to you. Okay, so in this construction that I want to show you, I'm going to use a diameter of 50 mm, and I will use the lead of 72 mm. So that's what I'm going to do. Let's look at the construction now. Now the first thing that you need to do is to draw a center line, horizontal center line. Draw a horizontal center line like this. Okay, so horizontal center line. Then we come to maybe in the middle of the line. So draw a vertical center line. Okay. All right. So the next is take your compass and measure 25 mm on your ruler, which is the half of the diameter given, 25 mm. So measure 25 mm. Put it at this point here and draw a circle. Draw a circle like this. Okay. So the next thing is divide this circle into 12 equal parts. Divide into 12 equal parts. So I'm going to use my set square to divide the circle into 12 equal parts. Okay. Okay. All right. Then we are going to do numbering. Now, when we want to number, you start from here. So this point is the starting point. So here we are going to put 0 at this point here. So this is 0 and this is 1. Here is 2. So here is 3. Here is 4. So here is 5. Here is 6. So this is 7. So this is 8. So this is 8 and this is 9. Here we have 10 and this is 11. Okay, so that's it. So we have done the numbering. So the next thing that we are going to do is that we are going to draw horizontal lines from each of these points, and we are drawing it to the right and also to the left. So starting from the point 0, so draw horizontal line. So draw horizontal line to the left and also to the right. So 1 and 11, they are at the same point. So move your set square there, draw a line to the left and you draw it to the right. So move to 2 and 10, they are at the same point. So draw a line to the left and to the right. So we have already done 3 and 9, so you don't have to do that again. So move to 4 and 8. So 4, 8. So they are the same point. So we draw to the left and to the right. Then 5 and 7, they are the same point. So draw the line, and 6 is the last one. So draw it. Okay, so that's the first part. So the next thing is, as we have said that the lead is 72. So move away from this circle on the right side, just a little bit, a little distance away from it. So draw a vertical line here, like this. And then you do the same thing, just move a little bit away from the circle. So draw a vertical line. Okay. So this point is 0, and this point is also 0. Alright, so the next thing that we are going to do is that, as I said, that the lead or the axial movement for one complete revolution is 72 mm. So come to this point 0 here and measure 72 mm. Take 72 mm. So this is for this is 72 mm here. Alright, so then we come to this, from this 0 measure 72 mm. So here is my 72 mm here. Alright, so this point here, so this point is 0. I'm coming, I will explain that again. So this point is also 0. You know, if you start from this point 0 and you are going, you are moving on this circle, you are moving on this circle, you are moving on this circle, you come back to this point. That is one complete revolution. You start from this 0 and you turn around and come back to this point 0. So that is one complete revolution. So that's why we have 0 here and 0 here, because by the time we move like this, so you come back to this point, and if you move from here, you come back to this point. Okay, so the next thing that we are going to do is that we are going to divide the distance 0 to 0 from here to here. That is 72 mm. We are going to divide it into 12 equal parts, as we have divided this circle into 12 equal parts. So we are doing it here, we are doing it there. So I believe you know how to do that. So that is how to divide a given line into a number of equal parts. So we are dividing this into 12 equal parts. I'm going to do that now. Okay, so the point have been, or the line has been divided into 12 equal parts by construction. That's divided into 12 equal parts by construction. Here, we have divided that 72 mm into 12 equal parts. So the next thing that we are going to do is that we are going to erect vertical lines on each of the points. So starting from here, let me start from 1. So you draw a vertical line. So draw a vertical line here. Okay, so you do the same for others too. So this is point 2. So you draw a vertical line on each of the points. So vertical lines have been drawn on each of the points. So the next thing that we are going to do is this. Just listen to me. Now, this is point 0, and this line, this horizontal line, comes out from this 0. So we look for the point of intersection of the horizontal 0 and the vertical 0. So this is the point of intersection. So they intersect here. Okay. So the same thing applies to this. They intersect here. So I'll be doing the two together at the same time. Then horizontal line 1 and vertical line 1, they intersect here. They intersect here. So let's put a dot at this point. So here we also have the same thing. Okay. Horizontal line 2 and vertical line 2, they intersect here. So here also we also have the same. So horizontal line 3, vertical line 3, they intersect here. And here also we have the same. Horizontal line 4, vertical line 4, they intersect here. So here we also have this point. So horizontal line 5, vertical line 5, they intersect here. Okay, so here, so we also have intersect here. Horizontal line 6, vertical line 6, they intersect here. So here we also have the same thing. Horizontal line 7, vertical line 7, they intersect here. So here we also have it here. Horizontal line 8, vertical line 8, they intersect here. So here we have the same. Horizontal line 9, vertical line 9, so they meet here. So we also have it here. Horizontal line 10, vertical line 10, they intersect here. And here also we also have this point. So horizontal line 11, vertical line 11, they meet here. They intersect here. Here also, this is 14. Sorry, this is 14. And this is 11. It's 11. Okay, so the last point is 0. So here we have what? We have this point. So we come back to this point 0. After we started from this 0, so we move like this and we come back to this point 0. So, and then the same thing also happens here. So we come back to this point 0. So these are the points. These are the points. Now there's something I need to let you know here. Now, look at this. We are looking at it in this direction. So the point starts from here and it goes starting from this left side, and goes to the right. So when the point moves from the left and stop on the right side, so we have what we call a left hand helix. So our left hand helix will be positioned here. But if the point starts from the right and end on the left side, so we call it right hand helix, and this is where we are going to put our right hand helix. Okay, now another important thing that you need to know is that look at this paper tape. It starts from here. If I'm looking at it in this direction, if I'm looking at it in this direction as it's facing me, it is facing me here. So if I'm looking at it in this direction, I can see the starting point. This is the starting point here. I can see the starting point. As it moves. When it gets to this point and it moves to the back, I will only see the movement from here to here. By the time it gets to the back, it is hidden from me. So if we are looking at it in this direction and it starts from here, so by the time it moves like this and it gets to this point, by the time it's coming down like this, it will be hidden from me. So the same thing applies if it starts from here and it's going like, by the time it gets to this point, coming down like this, it will be hidden from me. So I believe you know the type of line we are going to use for that. So we need our French curve now. So we are going to join this point together. And this will be drawn with thick continuous line because these are the points that we can see. You can see this point. You can see this point. Okay. And just check it easy. Okay. All right. So by time it's coming down, so I can start from here. So on this part it's coming down. So don't forget this will be hidden. We can't see this. It will be hidden from us. So we have to use short dashes line for hidden details. Okay. Okay. All right. So okay. So don't forget what I said, that when it gets to the maximum point, coming down, that part is hidden. So that's why we are using short dashes line to show the hidden detail or the hidden part of it. Okay. Okay. All right. So we move to this side now. So it starts from here and it is going like this. So by the time you get to this point, coming down like this, it will be hidden from, because this is the back side of the cylinder. So okay, so we have to take it easy so that the curve can be perfect. All right, so turn it to the other side now. So this is going to be hidden. So this will be hidden. So we use short dashes line to show the hidden details. Okay. just take it easy. Take it easy. Okay, so this is it. So don't forget, as I said, that when it starts from here, so it goes up. This will be made thick. By the time it turns to the other side, that is the hidden part. So that's why we use short dashes line to show that that part is hidden from us. So now, so this is our left-handed or left-hand helix, and this is the right-hand helix. So I'm going to dimension it and write those things there. So we have indicated all that we have talked about here. This is the left-hand helix and this is the right-hand helix. The movement from this point 0 to this point, which is the axial movement, which is called the lead, is 72. I've shown it here, and here also I've shown this. And the diameter of the circle that we used, or that is the circular base of the cylinder, is 50 mm. So the construction of an helix is as simple as I've shown here. So all you need to do is you can use the same dimensions to construct your own. And don't forget, keep on subscribing or subscribe to my YouTube channel, and whenever you subscribe, you get when you subscribe, whenever I upload a new video, you get a notification. So I really appreciate your love by keeping on going with my YouTube channel. So if you have any question or you have a comment to make, please, I would love your comment. And if you have any question, you can put it in the comment part, and I will respond to your request at any time. Thank you.